Hello everybody, Math Magic here, back again. First of all, I apologize for not uploading videos for a couple or 3 or 4 days, and I promise that I will try to maintain streak again. So today I came up with a very interesting RMO question which came in the year 1999, and it says if p, q and r are the roots of the cubic equation x cube minus 3px squared plus 3q squared x minus r cube equals to 0, then show p equals to q equals to r. Well, I have thought by solving a series of cases and then approach to the solution. So basically we will assume that p, q, r are the roots, right? Now notice this part. We know that the product of all the roots of a cubic equation is equal to the plus minus, so is equal to r cube, and this is coming from Vieta's relation. If you don't know or have doubt in what is Vieta's relation, I have uploaded a separate video which you will have to go and surely see it. Okay, come back to this question. Now notice I can write this as pqr minus r cube equals to 0. So pq minus r squared times r equals to 0. So here we have two cases, case 1 and case 2. Case 1 says pq equals to r squared and case 2 says r equals to 0. Well, let me first progress with case 2. Now, if r equals to 0, then I can say that this part of the equation pq plus qr plus pr gives us pq, and it is equal to plus 3q squared, right? So this again gives us pq minus 3q squared equals to 0, which gives us q times p minus 3q equals to 0, which gives us q equals to 0 or p equals to 3q. Okay, so here also we are approaching with two cases, case 2.1, case 2.2, and 2.1 says q equals to 0 and case 2.2 says p equals to 3q. I will first proceed with case 2.1. If q equals to 0, then we have p plus q plus r equals to 3p, which is possible only if p equals to 0. I'm talking about this part, minus 3p equals to p plus q plus r. Now q and r are 0, so this gives us p q r equals to 0, which is means for the statement of the question. Now coming to case 2.2, p equals to 3q. Now I will plug it here and I will get p plus 3q plus 0 equals to 3p. So this gives us 3q equals to 2p, and and gives us q equals to 2p by 3. Now we have p equals to 3q, so p equals to 3 times 2p by 3, which gives us p equals to 2p, and this is again possible only if p equals to 0. So this gives us p equals to 0, therefore q equals to 0 and r equals to 0. So case 2.2 is also for the statement. But coming to case 1, pq equals to r squared. Again I will plug into this 3q squared equation. I get pq plus qr plus rp equals to 3q squared. Now pq is r squared and these are qr and rp, so I will take r as common and p plus q plus r. This gives us 3q squared. So we can say p plus q plus r equals to 3q squared by r, and now we have this. Now this is again equal to 3p from this part, so we have 3q squared equals to 3pr, right? Now we can plug in the value of q equals to r squared by p. So we have, or better r, or better q only, let me plug in. We get r to the power 4 by p squared equals to 3pr. Now this gives us r to the power 4 minus 3p cube r equals to 0, 3r as common, and r cube minus p cube equals to 0. So since from here we are talking r and p and q as only integers, so we will basically take 3r equals to 0 or r equals to p. So if I get r equals to, okay, let me consider this case 1.1 and case 1.2. So case 1.2, if I go with it, we get pq equals to 0. That means either of p or q or both of them has to be 0. Okay, so now we plug into this symmetric equation p plus q plus r. We get any of those p plus q equals to 3p. Now this gives us q equals to 2p, but any one of them has to be 0. That shows that other has also to be 0. This gives us q equals to p equals to 0. Sorry for this lower bar, please ignore it. Okay, so this is showing r equals to q equals to p equals to 0, which is for the statement. Now coming to case 1.2, r equals to p. Now let's plug in. We get pq equals to r squared, which gives us pq equals to p squared, and this gives us p times q minus p equals to 0. So either of p equals to 0 or q equals to p. And I have taken that if p equals to 0, then I can show that q plus r equals to 0, which gives us q equals to minus r. And then I can, what can I do now? If I get q equals to minus r, okay, so I can plug it in into this equation. Qr plus pr equals to 3q squared. Yes, 3q squared. Now p is 0, and here also, so we have qr equals to minus r squared equals to 3q squared. So this gives us 3q squared plus r squared equals to 0. Yes, now notice that summation of squares to be 0 is only possible if q equals to 0, r equals to 0. This gives us p equals to q equals to r equals to 0. So case to 1.2's first part, or let me assume this to be case 1.2.1, is supporting. And now coming to q equals to p, now we have pq equals to r squared, so we have p squared equals to r squared equals to q squared. Now this gives us p equals to plus minus r equals to plus minus q. Now notice that this is, first of all, it is possible for p equals to q equals to r itself, and also it is possible for p. Now I have p equals to q, so r equals to plus minus r. I can just assume this part. Now I will plug in into the first part, so I get p plus q is 2p plus r equals to minus 3p. Now this is plus minus of p, so I don't know, plus minus p equals to minus 3p. Now this is possible only if wait, what is happening? Plus minus p is giving us minus 5p. Okay, nevertheless this is only true if p equals to 0, and thus we are proved that p equals to 0 gives us q equals to 0, and r is obviously 0. So from here we can show that p equals to q equals to r. Thus for all the cases from starting from the beginning till the end, p equals to q equals to r, and thus we are done.